Hello, everybody. This is Charles Anderson. I'm just a guy from Goodwell, Oklahoma, and we're on part 7, operators, and a little nod to arrays, +1. There's my mouse. Okay. Yes. We're continuing on with playing with Java, and especially the operators. We've already done unary operators, and so now we are on the additive multiplicative operators and how they're commonly used. So let's jump into that and pull up JMonkey Engine. Now, last time I forgot to leave the code for toBinary. It's just a little method I just whipped up because it helps to see the bitwise operations, and I forgot to lay that out for the last lesson. The very first one where there's a lot of playing with bitwise stuff. So let's get that out of the way first. Of course. Public static, it returns a string, and the name is toBinary. Public just means it's accessible to any class. Static just means that this is not meant to be replicated into the heap during instancing. There's just going to be one copy on the stack. So here's the integer that's converted, and it's convert int. So when you call it, you just, its signature is, well, let's see here, let's tab, I would need to wait, system.out.println, and then when, you just put in any integer, and of course the compiler automatically does integers, so, when it runs, toBinary. Okay, and we press play. Alright, so it translates it into binary notation, which you can actually type this in, and right here, 56. Alright, so this is now 56, and all you have to do to just verify that is to just go like my int, and then when you press play, 56. Obviously, if you were to put that in there the other way, but yeah, this is and signed would be the proper way to type it in for this value here. Because if you put a minus sign right there. Minus, and press play, minus 56. So, all right, so that's its signature. Final Boolean, that's because this is not needing to be changed at runtime, and because this is very strongly to do with this right here, which is one of the compound, assignment operators right there. But I'll go into that later. So we have final Boolean is signed, and I usually keep my final things as all caps, meaning this is kind of like a constant for the program. It does not change. It is a value, but it does not change. Then of course we've got a return string, which we will be returning, and then we've got our temp string, which we'll just be using inside to do some of the string working, and of course a little placeholder here so that it puts these dashes every 4. Okay, so the code runs, start doing this. If is signed and, the convert int is less than 0, which means it's negative. So if it needs the sign and it is negative, then we turn it positive here, because we're not wanting to worry about signs after this, because we're going to record the sign at the very front of the string. So we add the minus sign right at the very front of the string. Now, if the placeholder modulus 4 is 0, so if the remainder is 0, every 4 it's going to put out this. Now, the moment that it comes in here, of course, it's 0, right here. So it will automatically put out one of these things. All right. And that's actually taken care of right here by saying greater than rather than greater than or equal to. So, all right. So if our we increment our placeholder. I can do it pre or post. Doesn't really matter for the flow control here. Temp string then, concatenates the power of 2. It's kind of like the shift right, because shift right does by power of 2. And then, so the temp string gets that value. Now, what's going to happen is the string is going to be writing 1, 2, 3, 4, 5 as we go through this, but the actual order that it needs to be read in is dot, 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 dot. So we've got to reverse it. So what I do is, and here's a quick check. This is for the for the unsigned, because we're not multiplying by -1 here. If it's unsigned, so is signed, it would equal false, then we will get this negative number. All right, and the negative sign is slipped in there. So what I do is, well, when we run, we're going to be running this at least once. It's a do while. So I've got to make sure that that first number, if it's that, then I just need to make it that. If it's 0, obviously it's not going to have a negative sign on it. So, and then the sign gets discarded after that for an unsigned, because this statement here destroys the signed bit. So here's where I actually do the shift right, and I'm doing it 1 digit at a time, to match up with the characters. And then while it's greater than 0, just keep trucking. So yeah, unsigned would just this statement here destroys the signed bit if it's unsigned, and so it will be greater than 0. The signed method will not destroy the sign. That would be the other way, signed true, and so then it's automatically converted above 0 here. And so there we go. That way it'll pump through the number all the way. And then we'll start off our return string. There will be a minus sign if it's signed. And then it just adds that little 0b to notate binary. And then, this'll do it. This'll loop until it's processed the number. And then puts in that return string at the very, puts that one right there on the return string for the very first time. And because it flips over to positive here. Okay, so return string, that's put in there, and then we start parsing the string that we create here backwards. So we start at the top, and because this is an offset for an array, this little caret to make a string act like an array, then we've got to do -1 because it's 0 through 4 for an array of 5. So you're going to get 5 here, but you better -1 so that you don't go outside of the bounds. And then we go, and because I don't say equal to 0, it will drop off this very first little underscore right there. And then we go our decrementer for each time that it does, and all this does is it adds it as it pulls off in reverse order. So it goes, and for the return string. So, and then we return our return string. So that's the code for the toBinary, and it was just a little quick, throw it out there type thing. All right, now back on track. Okay, so additive multiplicative operators, plus, minus. Well, I've got the list right over here. Yeah, plus, minus. So let's just do some simple stuff, and let's use my int. I'll just, well, let's not have it as a negative. I mean, why have it as a negative? So yeah, you can just do like my int. We'll set it equal to. Just my int plus what, 4? Yeah, there we go. There's the plus sign. And now we're using this operator in its additive mode. And let's just. And there we go. So 56, add 4, and it's now 60. Do a quick minus. And 56, now it's 52. And multiplication. And now it multiplies to 112, and divide it. And it's 28. Now here, let's do something. 56. That would not be divisible by 5. Okay, yeah, that's an easy one. So we divide it by 5, and it's 11. Yes, 55, and 11 times 5 is 55, not 56. So, you know, the remainder's dropped because this is an integer, and that's where we can use our little buddy modulus to see, oh, there's 1 right there. So we could actually go system my int. Let's see. My int times 5. Let's go. Let's see. My int divided by 5 equals, well, you know what, let's just use the sign. Yeah, why not? There we go. Divided by 5 equals my int, and we'll need to do a concatenation for all of this. And that's division. And here's good old R from my school days, showing remainder. Let's go ahead and give it some spaces. Oh, I don't need quotes there. I needed parentheses. There we are. Alright, so let's, probably don't need this. Well, let's just get rid of this statement. There we are. So, 56 divided by 5 equals 11, remainder of 1. So, yeah, that's what I remember from good old school. Alright, so, let's see. That took care of that set. That was pretty easy. Alright, let's see, it's 131, so let's go ahead and go on to the next one. Now, we have shift operators, so left shift, right shift, and unsigned right shift. And, of course, we'll be using our Boolean function, you know, Boolean, toBinary function, excuse me, to have fun with this. So let's go ahead and get rid of this statement. Doop. And this one. And you know what? I'm done with these. Alright, so now we're on shift. Okay, so best way to do this is yeah, we'll use my int again, and yeah, we'll go ahead and use 56. So print line. There we go. And my int. Okay. Oh, toBinary, so that we can show it off. Although, you know what, I could probably say my int equals, there we go, that should work. All right. So what this all that does is just gives us our little number right off the bat, and now we can start doing the shift left and shift right. So my int, and notice I'm not doing the compound assignment operators quite yet. Equals my int, and we'll shift it to the right one. All right, and of course, if you'll remember what I said, it's easy way to multiply and divide by powers of 2. So show this off. We're going to shift it to the left by power 2. This would be like multiplying times 2, and yeah, we can just loop. Yeah, okay. Control Z that. Let's do it like this. Go from the end of the line. There we are. Okay, and I probably don't need that. Okay. So here's where we show our before and after. So yeah, multiply times the power of 2, and you actually just shifting everything to the left on the bit level, and so 56 times 2 is 112. There we are. And if you go and increase this, this shifts it 2 powers of 2. So 2 times 2 is 4, or 2 times 2 times 2 is 8. So let's multiply times 8. And there we are. And we're just moving it over 3 spots, but it's like multiplying times 8. There you go. All right, and then, oh, yes, a negative number. Should I go? I should go byte. Well, but then byte would throw in some stuff I don't really want to mess with. What was the max value? Well, I can find the max value right quick. What is max value? Let's print out. Because remember, there's that signed bit, right? And yeah, it'll definitely show you some funky stuff. So if I were to go print line my int dot max, how about int dot class? No, I know that there's a way to get this max value. And I don't even need to do, because watch this, all I have to do really is just say my int will equal -1. Okay, that sets all the flags. I could say complement 0 too. Whoop, there we are. So bitwise complement of 0, and we shift it left 1. And that will shove everything over 1, and then we'll shove everything over unsigned to destroy that signed bit. There we are. Okay, so this is my biggest number that I can do. And it's all it is it's just one less. That's the signed bit, so it gets rid of that, and so this is my maximum value. So if I want to show off, wow, I guess I just did. Yeah, if I want to show off the, okay, well, I just answered my own question there by going doofy, and I don't know the Java yet for finding the maximum value of a number, but this was a rather quick way, wasn't it? My bad. Wow. Okay. And of course, if you do the sign bit, then it preserves the sign, and so it's just -1. However, if I were to make this number equal that really huge value, right? Then when we shift left, it becomes a negative number. And then I can print it out again. There we go. So shift left, shift right sign, so we play that. So it becomes -2 here. You know, it starts off as this big number, then we shift it over to the left, which puts it in to the signed byte, you know, and of course it's -2 signed. And then we shift it to the right, and it preserves the signed bit on this one. And there we go. Now if I want to not let it preserve it, then shift and shift. So there you go. I guess that's really a cool way of explaining it, or at least, yeah, it occurs to me now that I've done it. Ooh, Resident Evil 6. Wow, I want to play that one. Anyway, but I'm recording. Okay, so 11:38. This should be good for now. I guess I'll just jump on to the next one then. Yeah. Okay. So this concludes part 7. Oh, let me let's see what we did. Additive operators. Yeah, that one was easy. Shift operators. That was kind of fun. I enjoyed that. Come on. I want to edit. And we'll save this as part 8. Well, I mean, just getting it ready for part 8. And that'll be operators plus 2. Okay, so, yeah, let me go and... Why am I doing this now? Hey, guys. Sorry about that. My distraction. So, for this one, I'm using JMonkey Engine. It's in Java. My name's Charles Anderson, indie game developer. My project's Idiog. I've got an email. I've got a Twitter. And see you on the next round, which should be up shortly. All right. Y'all have a good one.